Continuing our discussion about linear models, there's another type of word problem that is a little harder for us to come up with a linear model for. It just requires some extra steps, okay? I'm going to show you the word problem first, and then I'm going to go through what the steps are, okay? You're going to see real quick why this one is different, okay? This one says, a candle is 7 inches tall after burning for 1 hour, and 5 inches tall after burning for 2 hours. Okay, if you look really carefully, it does not say how tall the candle is at the start of it. It does not say after, or it does not say what the candle began at in inches. It doesn't tell us that. It starts by telling us immediately how tall it is after already burning for 1 hour. And then it just goes on to say how tall it is after burning for 2 hours, but it doesn't tell us how tall it was prior to burning. Okay, so we have no way of knowing in that 1 hour how far that candle burned down. Okay, so what we're going to have to do is we're going to have to identify and figure out what the starting point was, and we don't know the rate of change either. We have to figure out what the rate of change is. Okay, now this one you might be able to figure out by looking at the number, because look, if it's 7 inches after burning for 1 hour, and it's 5 inches after burning for 2 hours, how far did it go down in that 1 hour? Well, you could probably see it went down 2 inches. So you probably could already guess that the rate of change, or the slope, is probably -2, right? But sometimes the numbers won't work out so nicely where you'll be able to identify it that way. So we're going to actually represent it, okay, in just a minute by actually confirming that we are correct by using the slope formula, okay? What you have been given here, and this is very important, none of these numbers are a starting point, and none of these numbers are the rate of change. You don't see the words per or each, or feet per minute, or inches per hour. You don't see that, okay? So we're not been given the rate of change. We also are not told what the candle started out as before we ever started burning it. So we have no starting point, and we have no rate of change, no slope. So what is it that we have here? Well, we have 4 values. We have this 7 inches right here after 1 hour, and we have 5 inches after 2 hours, okay? So we still have 2 things here. We have an X and we have a Y, okay? Now we need to write down what those stand for. Remember, we talked about how the X value is your independent variable, okay? What it is that you changed, okay? What do you have control over in this candle story? Do you have control over the number of inches that it goes down, or do you have control over for how many hours you burn it, okay? You can't control when you burn it what the candle does, okay? You can't say, no, candle, you're not going to burn that fast, okay? The amount of time that you burn it for is your independent variable, okay? So your independent variable is the number of hours. Your dependent variable, the thing that is basically changing, is the inches that it burns down. Inches burned, okay? So you control the number of hours, and then the inches that are burned depends on what you do with the number of hours. Obviously, if you burn it for longer, your candle's going to burn down faster, and it's going to burn down farther. If you don't burn the candle for very long, if you don't have a large amount of hours that it's burning for, then it's not going to decrease. It's not going to get shorter, okay? So you have your independent variable. This is independent. What you can control is the independent variable. Oops, independent. This is the dependent. It depends on what you do with the rest. And you do have to know which one is which, because that's going to be really important in knowing how to set this one up. So I have been given some things, but neither of them are the starting point, the y-intercept, or the rate of change, which is the slope. What I've been given instead are 2 data points. 2 points or two solutions that satisfy that linear equation. I don't know what the linear equation is yet, but I do know that I have two data points. That's like having x1, y1 and x2, y2. And you probably remember that when we have x1, y1 and x2, y2, we can find the slope by doing the slope formula. Okay? Now I told you that in this particular example, the numbers work out kind of nicely, where you can actually probably gauge that the slope was probably -2 because in 1 hour's time, it went from 7 inches to 5 inches. So it's probably going to have a slope of -2. But we're going to confirm it with the slope formula, because sometimes you won't have that luxury of being able to just look at it because the numbers might not work out so evenly. Okay? So let's go ahead and fill in the notes here. The two data points are going to be written inside parentheses, okay? And when I write them in parentheses, you do have to put them in the correct order, okay? I have to know if it's the number of hours that comes first or the number of inches burned. So you do have to identify your independent and dependent variable in order to set these up correctly. In my example, the x value is the number of hours. So my 2 points are, after 1 hour, it burned down to 7 inches tall. And then my other one is after 2 hours, it burned down to 5 inches tall. There's my two data points. Two data points. They get written inside parentheses like an x1, y1, and an x2, y2. From there, I can still find out the linear equation, but I'm going to have to do a couple of steps. Because the first thing I'm going to have to do is find the rate of change, right? And then after that, I'm going to have to find the rest of the y-intercept, okay? So I'm going to be using point-slope form to help me, because in point-slope form, I don't have to figure out the y-intercept. I can just find the slope and then use one of the points in the equation and then convert it to slope or intercept form. So I'm going to use slope formula. That's my first major thing to do after I write the points. And I'm going to do that to find the rate of change. What is changing? Now, I still don't know the starting point. The starting point you'll find after you plug everything into point slope form. So I'm going to find the rate of change, which I think, remember, by the looks of it, is going to be -2, but I'm going to do slope formula in a minute. And then after that, I'm going to write the equation in point slope form. Point slope form, remember, is this: y minus y1 equals m times x minus x1. Okay? So what do I fill in again for those? Well, I fill in everything except the x and the y. So I'm going to plug in the slope that I find from step number 2 up there as the m. And then I'm going to choose one of my data points. It doesn't matter if I choose 1 and 7 or 2 and 5, but I'm going to use those points. Okay, I'm going to plug in one of the points as my x1 and y1. Okay? And then once I do that, if I want it to look like a linear model that's in slope-intercept form, I can just convert to slope-intercept form from point slope. Remember, point slope is only good for writing equations. It does us no good other than that. Okay? But it's going to allow me to get it into a format that I can then convert to slope-intercept form, because all of these are going to be in slope-intercept form when I write the model. Okay? So let's see if we're correct about the slope. So in order for me to write the equation, I'm first going to have to do the slope. So let's do the slope. I'm going to make this be my x1, y1. I'm going to make this be my x2. Whoops. I'm going to make this be my x2. I can't make that look right. x2, y2. Okay, so slope formula is y2 minus y1 over x2 minus x1. So y's are 5 minus 7. X's are 2 minus 1. 5 minus 7 is -2, and 2 minus 1 is 1. -2 divided by 1 is -2. We were right. It's going down 2 inches per hour. Okay? So now let me write the model, but let me start out by writing it in point slope form, and then I'll convert it to slope-intercept. Y minus y1. Y1, it doesn't matter which one I pick. I'll just go ahead and pick 7. Equals m. Remember, this is m. -2 times x minus x1. x1 is 1. I'm choosing this data point to use. From here, I just have to convert. Y minus 7 equals, I have to distribute, -2x. -2 times -1 is +2. And then I'm going to, in order to get it in the proper form, I'm going to add 7 to both sides. So my formula turns out to be, or my linear model is y equals -2x plus 9. So that means that before I started burning this candle, it started out as 9 inches tall, which makes sense because if after 1 hour it burned down to 7, and after 2 hours it burned down to 5, that means the rate of change is 2. So if I tack the 2 back onto the 7, that means I began at the beginning with 9 inches of candle. After 1 hour, it burned down 2 inches to 7, and then after the second hour, it burned down 2 inches down to 5. But this right here is my model. From there, I can either determine, I can put in the number of hours that I want to burn it for and find out when it turns, what the inches will be after a certain number of hours, or I can plug in a certain height and say to myself, okay, after a certain height, how many minutes will it take to burn to that height? Okay, so look at B. B says, how tall will the candle be burning after how tall will the candle be after burning for 3 hours? So I'm going to change the X, the number of hours that I'm burning it for. I'm going to burn it for 3 hours, and I want to know what that does to the value or to the amount of inches tall that the candle is. Obviously, we're burning it for longer than we've done in the example, so it's going to be even shorter than 5 inches. Okay, so -2 times 3, here, let me do it. -2 times 3 is -6, and then -6 plus 9 is 3. So it is going to be 3 inches tall after burning for 3 hours. That's how tall the candle is going to be. It's getting smaller, right? Now look at C. C says, when will the candle burn out? Well, when a candle burns out, what does that mean the number of inches are? Well, that means that y equals 0. We want it to be 0 inches tall, because when it's 0 inches tall, it has to burn out and the candle's done, right? How long will it take? How many hours will you be able to burn it for before it gets down to 0? That's the question, okay? So we're going to plug that into the formula. Okay, the formula, or the form is y equals -2x plus 9. Y equals -2x plus 9. So I want to know, when will the amount of inches burn out to nothing? So in order to do this, I'm going to have to solve for x this time. So I'm going to subtract 9 from both sides. Okay, that's going to give me -9 equals -2x. And then I divide by -2 to get rid of the -2 and solve for x. When I do that, I'm going to get -9 divided by -2 is going to be a positive. Remember, it wouldn't make sense to have a negative number of minutes, right? I want to know when the candle burns out. I'm asking, or how many hours, I'm asking how many hours it's going to take. You can't have a negative number of hours. So the fact that both of them are negative just means they're going to cancel. What you should recognize is that when you divide 9 divided by 2, and again, you can use calculators, you're going to get that x equals 4.5. What does 4.5 represent? Well, x represents the number of hours. So 4.5 means 4.5 hours later, your candle will burn out. It's a pretty fast burning candle. And it must be really small, because the fatter a candle is and the taller it is, especially if it's really fat, it's going to take a lot more than 4.5 hours for it to burn out. So this must be a fairly thin or skinny looking candle that in 4.5 hours it's already gone. Okay, most people can burn thick candles for probably 8 hours or more. Okay, so in this particular case, it must be kind of small, because after if we want to know how long it's going to take to burn out, we're asking to determine when will the amount of inches become 0. Well, it's going to take 4.5 hours for that to happen. Okay? So linear equations are kind of tricky. We have to be very careful that we first of all identify what is our independent variable and what is our dependent variable. That's a very important concept as we're trying to figure all this out. So you're going to be asked to do some more examples. I didn't give you a whole lot in your practice problems because there were some other things in this lesson that we didn't go into, like scatter plots and line of best fit or the trend line. We're not doing those particular concepts. So you only have assigned problems 1 through 7 as getting practice with setting up linear models. And again, in some of those examples, they're going to give you the starting point and they're going to give you the rate of change. But in other examples, they're going to give you 2 data points. And you've got more to do there. You have to figure out what the slope is or the rate of change by doing slope formula. Then you got to put it in point slope form and convert it to get the linear model in slope intercept form. Once you have that, you're going to be asked to do something with it. Okay? Either change the dependent variable or change the independent variable. So that gives you at least a little bit of a beginning point, and I'm going to see if I can identify some more practice problems online. So if you guys try 7 of those problems and still are having trouble being able to set up the equations, I've got some other ones available for you. So I'll kind of look for those and see if I can send some of those your way. But try the ones in your textbook first.